second traversing method is called as breadth first search. In breadth first search, it will proceed in a concentric manner by visiting first all the vertices that are adjacent to the starting vertex, then all unvisited vertices 2 edges apart from it, and so on until all the vertices in the same connected component as the starting vertex are visited. That means we are starting from a particular node and we are just checking what are the different adjacent nodes to this starting node, and we are visiting all the adjacent node one by one. Once all the adjacent nodes are visited, we visit the node which is 2 edges apart from this starting node, that is the node which is connected to this one. Okay, for example, if this is connected with 2 nodes, then I will visit these 2 nodes. If this edge is connected with 2 more nodes, I will visit these 2 nodes. Then I will connect this node, then I will connect this node. In next step, I will visit all the adjacent node which is connected to the 3 edges apart from this one, and so on. I will repeat this process until there is no any node which is not visited like this way here. From this starting vertex to the end vertex, we have to visit all the remaining nodes. We have to process like continuous here. Sometimes some nodes are not visited in one DFS, in one BFS, some nodes are not visited. In that situation, we have to start the algorithm again by selecting another vertex which is not visited. We have to apply the BFS again by selecting the new vertex and start the BFS again. Like that, we have to continue the process until all the nodes are visited. I will explain this with example. Now consider this here. Now consider this example here. I am starting from A. So I have visited here. I will mark with the dark color here. Next, some of the adjacent node for this A is D, C and E. So I have to visit all these adjacent nodes one by one. So I will visit first C and mark it visited. Then I will visit D, then mark it visited. Then I will mark E, then mark it visited. In this case, instead of traversing in the depth, I am traversing in the breadth. That means all the adjacent nodes of A are first visited. Then once all the adjacent nodes of A are visited, then I have to visit from the nodes which is adjacent to these 3 vertices. First I will pick the C, because C is alphabetically small, so I pick the C here. So from C I will go to F. D is already visited here, so this path is already done, so I go to F. Now F is visited here. To C, there is no any other additional vertices. There is no any additional vertices. Then I go to D. In D also there is no any additional vertices. So I go to E. Okay, to E, one more adjacent node is there, that is called as B. Okay, that's so I will visit the B. From E, I visit the B. So this is also visited. Okay, like that I will visit all the nodes in the graph in the breadth wise. So the output of this one will be like this way. First I will visit A. So I mark with the numbers This number indicates which node is visited when. First I will visit the A, then I visit the C, then D, then E, then F, then B. Now this technique is called as breadth first search. If you see this BFS diagram here, it's a tree here. This tree indicates first I am starting from A, then I will visit all the three adjacent nodes of A, that is C, D, E, and then I will visit from C to F, then I will visit from E to B. Now this dotted line indicates the cross edge. Cross edge means here, if you see here, between C to D, there is one edge is there. But I cannot visit D because I have already visited D using A. So this is a cross edge. Cross edge indicates there is the edge between C and D, but D is already visited. Okay. In similar fashion, there is the edge between E and F, but F and E is already visited. So this cross edge indicates the another node is visited. In breadth first search, it is convenient to use a queue. In depth first search, we are using a stack, but in breadth first search, we are using a queue to trace the operations of breadth first search. The queue is initialized with the traversal starting vertex. In our case, the starting vertex is our A. So in queue, we are initialized with a vertex called as A. Okay, which is marked as visited. Okay, A is actually initialized with the visited. Once on each iteration, the algorithm identifies all the unvisited vertices that are adjacent to the front vertex, marks them as visited, and adds them to the queue after that. In this case, first I will visit A, add that A to the queue, and mark it as a visited here. Okay, I mark this as a visited here. Then I will find out all the adjacent node of A, that is C, D, E. I will add that one by one to the queue. That is, first one I will add it to this C here, then I will add it to the D here, and I will add it to the E here. One by one I will add it to the queue. Then I mark it with here visited, visited, and visited. Okay, once you all the adjacent nodes are added to the queue, what you have to do next? After that, the front vertex is removed from the queue. In this queue, once you visit all the three nodes, that is C, D, E, I have to remove this vertex from the queue. That is, A is removed. Then I have to take the next node C and find what are the adjacent node for the C. The adjacent node for the C is actually F, only one. So I have to mark it visited here and add that node at the queue. There are no more nodes to the C, so I have to remove this from the queue. Then you have to check for the node D. From D, there are no any adjacent node which is not visited. So I have to remove that from the queue. Then I have to check for the E. From E, one node is there called as B, which is not visited. So I have to check that first. Okay, I mark that one with the visited here, then write into the queue here, B. Okay, once all the adjacent nodes which is not visited is added to the queue, I have to remove the E. Okay, I have to remove the E. There is no any adjacent node to E. then go for F. From F there is no any node which is not visited, so remove it from the queue. At the last you have B. B has no more adjacent node, so remove it from the queue. Once the queue is empty, our algorithms stops. The BFS algorithm stops when the queue is empty.